Starting the recording, and we're talking about fundamental trigonometric identities, so please start taking the notes. I will start with just putting some formulas, which everyone should be familiar with, and we will start. 1. Reciprocal identities. Reciprocal identities. Most of the stuff will be familiar to you. Maybe you can tell me what reciprocal identities are. Reciprocals are cosecant x, which is 1 over sine. Secant is 1 over cosine. And tangent 1 over cotangent. Alright, those are called reciprocal identities. If you don't know the name of this, it's totally fine, but you should know how they look like. Reciprocal. Number 2 will be called quotient identities. Quotient identities. And we're also familiar with those quotient identities. Those are tangent and cotangent. Tangent x is the ratio of sine over cosine. Let me write sine over cosine, and cotangent, thank you very much, cosine over sine. Now I'll give you 30 seconds to write it down, and we will move into Pythagorean identities. All right, moving on.
Wait, please.
Okay. Thank you. Number 3, Pythagorean identities. Pythagorean identities. Who can tell me Pythagorean identity? Prim, go ahead.
Sine squared plus cosine squared is 1. Tangent squared plus 1 equals secant squared. Cosecant plus 1 equals tangent. Cotangent squared.
Thank you. So let me only memorize this one. I told you not to memorize the other two, but if you know, it's great. But I prefer not to memorize too much stuff, just because. Okay, I know this. This is called fundamental Pythagorean identity. If you know this, bless you. From there, you can get 2 more. So let me get 2 more from there. Let's scroll it a bit. So let me copy this Pythagorean trigonometric identity, and then each term I will divide by either sine squared or cosine squared.
Why do you do that?
To get another 2 identities. So Rim told me 3 identities, but I don't remember the other 2. This means I can just copy this one, and now I will divide everything by cosine squared, by cosine squared, by cosine squared. And I can simplify because sine over cosine is tangent. So this could be tangent squared plus 1, and 1 over cosine is secant squared x. So this is second identity which we can use. And again, you don't have to memorize because you can do it in one step. And I will do the same procedure, but now I will copy the trigonometric identity and divide by sine squared. Sine squared plus cosine squared equal 1. Now I'm dividing everything by sine squared. Sine squared over sine squared over sine squared. And this is 1. Cosine over sine is cotangent. Cotangent squared equal 1 over sine, which is cosecant. Cosecant squared x. This is my second identity, which I can use as well. Which also will be very useful for the benchmark. Right, a bit more formulas after that. Let me give you 15 seconds to finish writing. Thank you. You're very welcome. The next is cofunction identities. So number 4, which we already learned and kind of reviewing today. Cofunction identities. cofunction identities. Cofunctions of complementary angles are
Complementary.
cofunctions equal. Cofunctions of complementary angles are equal, which means cosine of pi over 2 minus theta will be equal to sine theta, because they are cofunctions. And if I will not write all of the cofunctions here, I will also write tangent, for example, of pi over 2 minus theta, that will be equal to cotangent. And secant of pi over 2 minus theta equal to cosecant theta. Okay. We have cofunctions. And last one are even and odd. And now we'll do some practice examples. All done?
Yes, ma'am.
All right, number 5. Even odd. Even odd identities. So the only even function is cosine, which means, let me start with even. Even is cosine, which means cosine of minus x equal to cosine of just x. So equal to cosine of just x. Since it's even function, then minus x, minus doesn't matter. Well, if cosine is even, it means secant has to be even as well. Secant of minus x equal to secant of just x. So this is the only even function. All other functions are odd. Now let me give a couple examples of odd functions. Odd. For example, sine is odd. Sine of minus x will be equal to
Negative sine of x.
Thank you. Well, maybe I can do tangent as well. Tangent of minus x equal to minus tangent x. All right, that's it. That's it with the formulas. And now we'll go over 4 more examples. I will go over very, very popular examples, which those who did not take SAT yet might also see there. And of course on the test, which will be on Monday. Let me scroll up. Example 1. Example 1, I will ask you to simplify sine x times cosine squared x minus sine x. You can go ahead and start working on that, and I will do it on the board. I will factor sine x out. Sine x factoring out. Then cosine squared x minus 1. So let's think how I can replace cosine squared x minus 1. I will use Pythagorean identity. Let me scroll this. Alright, I'm using sine squared plus cosine squared equal to 1. Let me subtract 1 to both sides and minus sine. I'm subtracting sine first. Minus sine squared. This goes away. And I will then subtract 1 from both sides. Minus 1, and I will have cosine squared minus 1 equal to minus sine squared x. So I did this to replace this part. You see this part and this part are the same. So now this part I will replace with minus sine squared. Let me change different color, and I will take this and I will put instead of cosine squared x minus 1. Can now someone tell me the final answer for this?
Negative sine.
Yes. There you go. There's 3 more examples. Example 2. Let's move to example 2, and I will ask you to simplify this question. Example 2, mark it as a very important 5-star example, which you should review for the benchmark. tangent theta plus tangent of minus theta. Let me put this in a parenthesis or brackets times cosine theta plus cosine of minus theta. So please look at the first part and tell me tangent of minus theta equal to
Negative tangent.
negative tangent, because tangent is odd. So tangent theta, and instead of this part, I will write minus tangent theta, because tangent is odd function, and I don't really care about the rest because this portion is 0. So if this is 0, my answer is 0. Example 3. Have 2 more examples and we will be done with the notes. Example 3. Prove that sine squared theta minus cosine squared theta equal to 2 sine squared theta minus 1. So I have to prove that this is a true identity. I will prove by just some algebraic manipulations and simplify. And when I will end up with one of the formulas we started the lesson with, then I will be done. For example, what do you think I can do? What should be my first step in simplifying it? What can I do? What can I do?
Subtract sine of both sides.
Let's subtract sine from both sides. That sounds like a good idea. Subtract minus sine squared. We will have minus cosine squared theta equal to sine squared theta minus 1. Maybe I can subtract another sign over here. Let me subtract another sign from both sides, and my left side turns into cosine squared minus sine squared equal to minus 1. And I'm allowed to multiply both sides by the same number. What do you see? What's the name of this? Pythagorean identity. So I'm done. I can just write Pythagorean identity, and I'm done. And you know what mathematicians say when they're done? Teenagers say period, and mathematicians say QED. QED. Quod erat demonstrandum. That means that's what I proved. I'm done.
Say that again?
Quod, I will write it down. Quod erat
What?
demonstrandum. That's from Latin.
Quad anonymous. You know,
Quod erat demonstrandum.
Is that Latin?
Latin.
Is that Latin?
That's Latin. So literal translation is.
Period.
That's your literal translation. Or that what I had to prove.
Period, or should I say quad and demonstration?
Yeah, that sounds better. Alright, last example. I promise you, last example.
what?
You said that last.
Magnificent.
I said second to last. Now it's last. Last example. You will have very, very similar question on your benchmark. So example, I don't know what number.
4.
Example 4.
It's
I told you 4 examples. So example 4.
this is 3.
How about?
I mean, yes.
So I need to simplify that, but I don't really have any formula to simplify. You'll have very, very similar question on the test. Very similar. So let me try to do it analytically. Let me try to graph sine and find angle theta. So if theta is here, then pi plus theta, or theta plus pi, will be somewhere here. Theta plus pi. And I know that sine is a vertical change. This is my sine. And this is my sine of theta plus pi. So how can they relate? So they have the same value, but opposite sign. They have opposite sign. This is positive, this is negative. So I can write this as minus sine theta. And we are done. Alright, I'll stop the recording now.